Okay, so we'll be talking about rational exponents, and rational means fractions, exponent means the number above the variable. So we're going to have fractional exponents. And before we actually do that, let's go over our exponent rules so we can ensure that we understand them. So the first one, remember, was a to the n times a to the n means you can add the exponents. If there's a division, then you subtract to the 0 power is 1, and so forth. So what I'm going to do really quickly is just go over a few examples to show you that they actually work out the way that they should. So for example, x squared times x to the third. If we were to actually write that part out, remember, it's x times x times x times x times x. So the first two is the square, and then the last two is the cube there. But remember, exponents are repeated multiplication. So we repeated the multiplication 5 times. So this is just going to be x to the 5th. But that's the same thing as just adding the exponents. So that's the reason why this one works out. This one over here, if you have x to the third over x squared, well, this is x times x times x. The bottom is x times x. And then we can cancel straight down. So we have x to the 1. And that is going to be 3 minus 2. So this one follows like that. This one is a little bit trickier, but it's not too bad. What I'm going to do is I'm going to invoke the division rule by saying x to the third over x to the third. The division rule says this is 3 minus 3. Right? And 3 minus 3 is 0. So this is x to the 0. But what is anything divided by itself? It's 1. So x to the 0 is 1. Alright, the negative exponent one is going to follow by the division rule as well. But what I'm going to do is I'm going to do it with squares on the top and then cube on the bottom. So x times x over x times x times x. These cancel, and you're left with 1 over x. But by the division rule, this is x to the 2 minus 3, which is x to the negative 1. So the negative brings the the variable down to the bottom, and all we're doing is erasing the negative sign to write it as 1 over the rest. This one over here, the distribution of the exponent, is saying x over y to the third is x over y times x over y times x over y. Because we're repeating the multiplication 3 times. But from our fraction rules, we know that multiplication you just multiply straight across. So this is x times x times x, y times y times y, or x to the third over y to the third. So the exponents distribute in division. Similar to here, x squared to the third is x squared times x squared times x squared. The multiplication rule says to add the exponents, which is x to the 6th. So repeated addition is multiplication. So since you repeated it 3 times, it's 3 times 2, or that 3 times that 2. And this last one, this one's a little bit more complicated. But remember, what you're doing with the nth root of a is you're asking yourself what times itself n times. So what times itself n times is going to give you the a value. Right? So what we're trying to find is, sorry, this is equals. Let me rewrite this. This is equal to some number where that number to the nth power is a. Right? Because we want to multiply to itself n times to get a. Well, using the multiplication, the exponent rule up here, a to the 1 over n is equal to a 1 over n times n. These cancel, they're just left with a. So the thing that was inside of here is the solution to this nth root. So this is just a to the 1 over n, which is exactly what we wanted here. So let's go ahead and do some of those examples, and we'll see how all of this works. Okay, So our first example is going to be 4 raised to the 2 over 3. And what we need in order to do this is a rule. So the nth root of a to the n is equal to the nth root of a raised to the nth power as long as this thing is real. So we cannot have a complex number on the when we evaluate the nth root. So we cannot have, for example, the square root of -2 in there. So this is the restriction on when you can do this. And what we're going to do is we're going to use the square, the 2 over 3, and rewrite it as a square root or a cube or a fourth root, so we can simplify this a little bit more. So does everyone see that this is 4 squared? Sorry, we'll write it one step at a time. Squared times 1 over 3. Because 2 times 1 over 3 is 2 over 3. Now, what we can do, right, is we can rewrite this as 4 squared to the 1 over 3 by our exponent rules. Let's say exponents raised to exponents is multiplication. The 1/3, though, is the third root of 4 squared. The third root and the 1 over 3, they're interchangeable. So what I'm going to do now is I'm going to write this one out as 2 times 2 times 2 times 2. Because the first 2 here and that 2 over there are both 4s. So it's 4 times itself, or 4 squared. This 3 right here is telling us to look for a group of 3. I can pull one of them out, and whatever is left over stays on the inside. So we can convert this 4 to the 2/3 into 2 third root of 2. Now, the practicality of either one is dependent on what you're doing. My personal preference is actually to just leave it like this, but in some cases you might need to write it in this form. So the practicality is dependent on what you're trying to do. So let's go ahead and do one with variables. That's a little bit more complicated. What we're going to do in this problem, though, is we're going to try to combine it all into a single, or simplify it as much as possible. So the first part stays the same, but the second part is n to the third raised to a half, because this is a square root and can be written as a half exponent. Now, this one over here, you could rewrite the n to the -2 as 1 over n squared, but because we already have a multiplication rule for exponents, it's easier to just leave like that. So the next part I'm going to do is I'm going to use the commutative property. So I'm going to change the order because multiplication is commutative. So 2 times 4 times 4, n squared. This over here, whenever you have a multiplication, they multiply straight across. So this is going to be 3 over 2, n to the -2. Now, this part over here, you can do the arithmetic. This is going to be 8 times 4, or 32. And when we have multiplications with the same variable, you add the exponents. So 2 plus 3 over 2 minus 2. The 2 and the -2 cancel, so this is just 32 n to the 3 over 2. Now, if you want to, you can do the same thing that we did over here, which is convert it into 32m cubed raised to the half power, which is 32 square root of m cubed. But again, my personal preference is to leave it in this one.